Good evening, number 5. This may be our last online lesson. Who knows? Well, maybe it's the cold weather. I begged people to come help. Nobody, nix, nada. Even asked my neighbors. No, nothing. Not even a dog. Okay, so let's just get going with this whole thing. I think it's just started to record now. You missed my introductory speech. We're carrying on with complex numbers, and you're going to need a worksheet for session 19, which is called Equating the Real and Imaginary Part of Complex Numbers. Okay, you can print that out or save it or whatever. Okay, last session, let's go. Let's share the screen. And there we go. Okay. So, with complex equations, just a reminder, your key idea is that I squared is equal to -1. In other words, the square root of -1 is equal to I, your imaginary number. Okay. And then, just like when we solved cubic equations, we equated coefficients of x squared and x, etc., and constants, which basically said concept of equating coefficients is the x squared on the left-hand side of the equation must be equal to the x squared on the right-hand side of the equation. Okay, so their coefficients must balance. Okay, and x's on both sides must balance, etc. It's the same thing with the real part and the imaginary part. I've lost my lovely yellow pen. The real part and imaginary part of complex numbers. Okay, so they must also balance. For example, in this equation over here, we've got 2 plus bi is equal to a minus 4i. The real part on this side is 2 and on that side is a. So the equation, you're told it's balanced, so that must be equal to that. So 2 must be equal to a. And the imaginary part of the equation says that bi is equal to -4i. So b must be equal to -4. You're just equating. Okay, the real part and the imaginary part must balance, and that's the key idea. The other key idea is when you're dividing complex numbers, multiply the top and the bottom, the numerator and the denominator, by the complex conjugate of the denominator. What the hell is that? A complex conjugate. Well, if you had 2 plus 5i, that was z, then the complex conjugate, which we would call z star, sometimes it's called z bar, same thing, it would be 2 minus 5i. Basically, you're simply changing the sign of the complex part, the imaginary part of the equation. Okay, so z is 2 plus 5i, then the conjugate of z, which could be z star or z bar, is 2 minus 5i. And you're going to times the top and the bottom by the complex conjugate of the denominator. So try this on your own, see if you remember. Okay, press pause, give it a go. 2 plus 3i divided by 1 minus 2i. Go for it. Okay, so we're going to multiply the top and the bottom. The complex conjugate of 1 minus 2i is 1 plus 2i, but we've got to balance that by timesing the top by 1 plus 2i, because then effectively you're doing nothing to the equation. You're timesing the top, you're timesing effectively the equation by 1. So if I multiply the top, I'm going to get 2 plus 4i plus 3i is plus 7i. And then I'm going to get 6i squared, okay, all over 1, exactly the same, so 2 times the first and the last, minus 4i squared. You can skip out steps. So I end up, well, 6i squared, I squared is -1. So that's going to be I squared is -1, -6 plus 2 is -4, plus 7i, okay, and 1 minus 4i squared, well, I squared is -1, so it'll be 1 minus 4 times -1, which becomes 1 plus 4, which is 3, okay, so your answer is -4 plus 7i over 3. If you want, you can write it as -4 over 3 plus 7i over 3, which is usually what you have to do because they say write it in the form a plus bi. Split it into its imaginary part and its complex part. So that's how you're going to multiply, divide out one complex number by another complex number. Easy peasy, lemon squeeze. Right. So now let's look at this concept of equating coefficients. So the question says solve for A and B. Okay, there's A and B. And you want to look, the concept we're going to use is that the real part of the equation must balance out with the imaginary part of the equation. So the first thing we're going to do is make our lives easier, simplify this side. So go work out 1 plus I times 1 minus I. Okay, and it's going to be equal to 1 minus I squared times, that's 1 plus I times 1 minus I, times A plus BI is equal to 10 plus 16I. Okay, I squared is negative 1, so it becomes 1 minus minus 1, which is 2. So you get 2 times A plus BI is equal to 10 plus 16I. Well, we can make our lives easier by dividing both sides of the equation by 2. So you're going to get, therefore, A plus BI is equal to 5 plus 8I. And now we've got it in a form where I can equate the real part with the imaginary part. So if I look at the real parts of that equation, okay, well, the real part on the left-hand side is A, and the real part on the right-hand side is 5. So they must balance. The real part of the equation must balance. So A is equal to 5. And the imaginary part must balance as well. Okay, and the imaginary part on the left-hand side is B, and the imaginary part on the right-hand side is 8. So using the imaginary part, we know that B is equal to 8. So basically your process is always going to be to simplify, okay, and then equate the imaginary part with the real part. Okay, right. The next type of question that we get is a pretty common one, where you get your letters here, your A and B, whatever you're looking for over there, and we get a complex number over here. So you get, that says, believe it or not, you got letters over there, that's what that says, and you've got a normal complex number over there. Okay, and there are two ways we can approach this sum. Okay, the one is to get the letters on its own. So method 1 is by dividing by the normal complex number. And it's probably the bit of the quicker way. So I divide both sides by 3 minus I. So if I divide both sides by 3 minus I, on the left-hand side, you're going to be left with A minus BI. And on the right-hand side, you're going to have 2 minus I divided by 3 minus I. Right. Now go do that division. Okay, how are you going to do the division? Okay, you're going to multiply the top and the bottom by the complex conjugate, okay, of the denominator. Okay, and then you're going to simplify. Okay, and then I want you to equate the real part with the imaginary part after you've done that. Right, press pause, and off you go. Okay, so you're going to times the top and the bottom by 3 plus I, 3 plus I. Remember, you're not doing anything, you're timesing it by 1. And you get, therefore, A minus BI is going to be equal to, well, on the top we've got 2 times 3, which is 6. Plus 2I minus 3I is minus I. Then you're going to have minus I squared. We're going to start skipping out steps. Minus I squared means minus negative negative 1, which is plus 1. So you're going to get 6 minus I plus 1. Okay. And at the bottom, you're going to have 9 minus I squared, which is going to be, I squared is negative 1, minus I squared is going to be plus 1. So you get, therefore, A minus BI is equal to 7 over 10 minus I over 10. Right. So now we've got the equation, now we've got the complex equation simplified so that I can equate the real parts and the imaginary parts. And if I look at the real parts on the here, that must be equal to that. So looking at the real parts, please tell your marker what you're doing. Okay, so write down real. A part is equal, A is going to be equal to 7 over 10. And if you look at the imaginary part, on the left must be equal to the imaginary part on the right. So what's the coefficient of I there? It's negative 1 over 10. So you've got negative B is equal to negative 1 over 10, implying that B must be equal to 1 over 10. So there are your solutions. Okay. The second part, in a case like this where you've got letters times by a normal complex number is equal to another normal complex number, is to multiply out, okay, equate coefficients, and solve the two simultaneous equations which you get. Solve the simultaneous equation. So times out, equate coefficients, solve simultaneously. So if I times out this equation, a minus b times 3 minus I, I'm going to get 3a minus ai minus 3bi, 3a minus ai minus 3bi plus bi squared, and bi squared, so you're going to get bi squared, okay, I squared is negative 1, so bi squared is going to be negative b. Okay, so I get 3a, by timesing those two out, that's what I get over there. Okay, that times out to that, and that must be equal to 2 minus I. Okay, so if I get the real parts together, I'm going to have 3 minus a minus b is the real part here. If I take out I, I'm left with, from these two terms, I'm left with negative a minus 3. So I can think of that as a coefficient, because it could be that times I. Okay, so 3a minus b, that's the real part. The imaginary part of this is minus a minus 3. Okay, and that must be equal to 2 minus I. So now if I equate parts, and I look at the real part, on the left-hand side, what's the real part? The real part is 3a minus b, and on the right-hand side, it's 2. So I get 3a minus b is equal to 2. I know that I'm going to have to solve simultaneously, so let's isolate one variable, doesn't matter which one. B is easier to isolate, so I get 3a minus 2 is equal to b, and that's my equation 1. Remember, to solve for two variables, you need two equations, okay, and then you solve simultaneously. If I look at the imaginary parts of these equations, well, the imaginary part on the left is negative a minus 3, must be equal to the imaginary part on the right, which is negative 1. The coefficient of I is negative 1. So that's negative 1i. Okay. So minus a minus 3. Oh, this is going to be easy. Hang on, I've done something wrong. There must be a b in here. 3a. Oh man, I made a big mess up over here. Sorry. Okay. That's minus 3. Hopefully you're all screaming at the screen. That's minus 3bi. Okay. Minus 3bi. So it's a minus 3b. Okay. No doubt I've got a WhatsApp by now, I'm sure, saying, oh, you idiot. Okay. So this imaginary part is going to be minus a minus 3b is equal to minus 1. Okay. Okay, 3a minus ai minus 3bi. Yep, sorry about that. Be careful. And this is also wrong. Sure, my brain's not here. It's been a long day sitting an AP exam. This is going to be plus bi squared. No, it is right. Minus b. Okay. So that's my second equation. Okay. So I'm going to substitute 1 into 2, which simply means wherever I see a b, I'm going to replace it with 3a minus 2. So I get minus a minus 3 times 3a minus 2. I've replaced this b over here with 3a minus 2. Okay, so minus a minus 3 times 3a minus 2 is equal to negative 1. So therefore minus a minus 9a plus 6 is equal to negative 1. Okay, so minus a minus 9a is minus 10a is equal to minus 7. Divide by negative 10 and I get a is equal to 7 over 10, which is a relief because it's the same answer as what we got here. So a is 7 over 10. And now if I'm going to sub back and solve for b, well, the easiest place to sub back into is into equation 1, which has isolated b already. So b is going to be equal to 3 times a, which is 7 over 10. 3 times 7 over 10 minus 2. And you're going to get 3 means 3 over 1, so you get 21 over 10 minus 20 over 10, which is, you can just use your calculator, 1 over 10. So I get A is 7 over 10, which is what I wanted, and B is equal to 1 over 10. So fantastic news. Either method is fine. It's up to you. Okay, whatever you prefer. I think this way is probably a little bit quicker. Okay, letter times a number. Right, so I've got one for you to try by yourself, and I want you to try both methods for this one. After that, you can pick whatever method you choose. So the question is, 4 minus 2i times a minus bi is equal to minus 4 minus 38i. Right, press pause and try method 1. By method 1, which means I'm going to divide by the normal complex number. Remember, the scenario is you've got a normal complex number, and you've got one of the letters. Okay, and your first option is to divide both sides by 4 minus 2i. Okay, the top end, okay, so divide by 4 minus 2i. Right, go for it. Try that method. Press pause, try it yourself, otherwise you're wasting your time. Right, so hopefully you've tried it now, and you're just checking. If I divide both sides by 4 minus 2i, I'm going to be left with a minus bi is equal to minus 4 minus 38i over 4 minus 2i. Okay, and to sort out this mess, okay, so you're going to have a minus bi is equal to, well, you're going to times the top and the bottom by the conjugate of the denominator, which is 4 plus 2i. Okay, and you're going to get minus 16, okay, minus 8i. I'm going to need a calculator here. 38 times 4 is 120. 8 4s are 30, should be 152. Let's just double check. 38 times 4 is 152. Yeah. Minus 152i minus 76i squared. Okay, sometimes actually it's quicker to write out everything than to do shortcuts, because often you end up making careless mistakes with shortcuts. At the bottom, you're going to get 16 minus 4i squared. Right, so therefore a minus bi is going to be equal to, well, minus 16, I squared is negative 1, so minus 16 plus 76. 76 minus 16 is 50. And this is going to be minus 160i. And that's going to be 16. I squared is negative 1, so it becomes 16 plus 4, which is 20. Okay. So I end up with a minus bi is equal to 50 over 20 minus 160i over 20. And if we simplify that, I get a minus bi is equal to 5 over 2. 160 divided by 20 is 8 minus 8i. Then if I look at the real part of the equation, there's the two real parts. I'm going to have a is equal to 5 over 2. And if I look at the imaginary parts, I'm going to have negative b is equal to negative 8. Okay, in other words, b is equal to 8. Right, hopefully I haven't made some careless mistake. Okay, so either you're normally going to pick one method or the other. So that's the first one, to divide by that. The second method, remember, was to times out. Okay, equate coefficients of the real and the imaginary, and then solve simultaneously. Right. So if I times, so go try that method. First of all, go times out. Okay, off you go. Equate coefficients, solve simultaneously, and off we go. So you're going to get 4a, okay, minus 4bi minus 2ai plus 2bi squared, and 2bi squared is going to be 2b times I squared is 2b times negative 1, which is negative 2b, so it's going to be minus 2b, okay, and plus 2bi squared, okay, minus 2b, and then that must be equal to minus 4 minus 38i, okay. Let's get the real parts together. So the real part here is 4a minus 2b. Okay, so I'm going to have 4a minus 2b together. And then the imaginary parts, if I take out I as a common factor, you're going to have, always take out plus I, you're going to be left with minus 4b minus 2a. So that's that bit over there, because now I can see the coefficient of I, which is minus 4b minus 2a, must be equal to minus 4 minus 38i. Okay, now I need to equate the coefficients. So I'm going to get the real parts on the left of 4a minus 2b must be equal to the real part on the right, which is minus 4. Let's make our life easier by dividing by 2. So I'm going to get 2a minus b is equal to minus 2. And let's isolate a variable. So 2a plus 2 is equal to b. And we'll call that equation 1. Okay, so b is equal to 2a plus 2. I hope you've done some French equations, just assuming you have. Right, so b is equal to 2a plus 2. All right, now I need a second equation, and to get the second equation, I'm going to look at the imaginary part of the sum. I've looked at the real parts. Okay, now I'm looking at the imaginary parts. So minus 4b minus 2a must be equal to minus 38. Those are your imaginary parts. And we can divide by 2 to make our life easier. Minus 2b, let's divide by negative 2. So you'll get 2b plus a is equal to 19. Call that equation 2. And if I sub 1 into 2, which simply means go replace every b in this equation with 2a plus 2, I'm going to get 2, I'm replacing b with 2a plus 2, so I'll have 2 times 2a plus 2. Remember, I've got to get an answer of a is 5 over 2, here's hoping. 2 times 2a plus 2 plus a is equal to 19. Okay, so I'm going to get 4a plus 4 plus a is equal to 19. So 5a is equal to 19 minus 4 is 15. And I've messed up somehow. So I got a is equal to 3. Okay, so let's see. 4a minus 2b is equal to minus 4. 2a minus b is minus 2. 2a plus 2 is equal to b. That looks right. 4a, you can't press pause on these videos, I'm sorry. So 4a minus 2b, imaginary part is 2 minus 2ai, okay, minus 4bi. So I minus 4b minus 2a is equal to minus 4 minus 38i. So 4a minus 2b is minus 4. So 2a minus b is minus 2. So 2a plus 2 is equal to b. And the imaginary part, 4a minus 2a is minus 38. If I divide by minus 2, I get 2b plus a is equal to 19. And 2 times b is 2a plus 2, plus a is equal to 19. So 4a plus 4 plus a is equal to 19. So 5a is equal to 15. So a is equal to 3. And if I made the mistake on this side, and if a is equal to 3, b must be equal to 2a plus 2, which is 8. b is 2a plus 2. Okay. b is equal to 2a plus 2. So I think this is right. So 2 times, I must have made a mistake over here. b is equal to 2a plus 2, but a is equal to 3. So a is 3 and b is 8. So the mistake must be somewhere over here. And 50 over 20, it should be 60 over 20. It was probably some stupid mistake. Yeah, one stupid mistake. You can see how it can cost you. 76i squared, 76 minus 16 is not 60. It's 50, it's 60. Okay. 60 over 20 gives us 3. So a is equal to 3. Right, sorry about all of that. Okay, but just to show you, we're all human. Okay. I'm only human. Right, okay. So, I better put a message on your notes. Wait till the end of the sum to spot the errors. Okay. Right, last question, which is just as well, considering the mess up I'm making. Example 4. Determine a complex number, z is equal to x plus iy. So my objective is to find x and to find y. That satisfies the equation 3z minus I times, we read that as the conjugate of z is equal to 16. We expect you to know that, but they've told you here where z star is the complex conjugate of z. So to start off, we're just going to sub in, and z is equal to x plus iy, 3 times x plus, it's just like solving for a and b, but they call it x and y. 3 times x plus iy minus I times, now if x plus z is equal to x plus iy, then the conjugate of z is equal to x minus iy. So I get minus I times x minus iy must be equal to 16. Okay? And if I go simplify this, I get 3x plus 3yi minus xi minus I squared times y is 1 times y, which is y. I squared is negative 1, so it's 1 times y, which is y. So that's going to be plus y. Minus I times minus iy is going to be plus I squared y. I squared y, which is negative 1 times y, which is negative y. Plus I squared is negative 1. Yeah, negative y. Negative I squared plus I squared. I squared is negative 1. Yeah. I squared. So that should be negative y. Okay, I squared is negative 1. Negative 1 times y. Negative y is equal to 16. Okay, I squared negative 1 minus 16. All right. So now, if I equate the real part and the imaginary parts, okay, from the real part of the equation, well, let's put the real parts together. I'm going to get therefore 3x, okay, minus y plus I. If I take out I from these two, I'm going to get 3y minus x is equal to 16, right? So if I look at the real part of the equation, 3x minus y must be equal to 16. Okay, right? And if I look at the imaginary part of the equation, let's isolate y. So from here, I'm going to get 3x minus 16 is equal to y. Let's call that equation 1. And if I look at the imaginary part of the equation, okay, here was our real part. The imaginary part, we're going to have 3y minus x, and there's 0i over here. It must be equal to 0. There's no imaginary part on the right-hand side. And if okay, so we can simplify that if we want and get 3y is equal to x. So I could sub 1 into 2 or 2 into 1, makes no difference. Let's sub 1 into 2. Sub 1 into 2. Okay. So wherever I see a y here, I'm going to replace it with 3x minus 16. So I'm going to get 3 times y is 3 times 3x minus 16 must be equal to y. And I'm going to end up with a quadratic. So I'll get 9x squared minus 48. Sorry guys. 3x minus 16 is equal to y. I'm subbing 1 into 2, so I'm replacing y with 3x minus 6. 3 times 3x minus 16. Okay, y 3x minus 16 is equal to x. I've subbed y is equal to 3x minus 16 into there, so 3 times 3x minus 16 is equal to x. 3 times 3x minus 16 is x. So therefore 9x minus 48. Okay, 3. So 9x minus 48. 3 times 3x minus 16 is equal to, yeah, so 9x minus 48 is equal to x. So I end up with 8x is equal to 48. Divide both sides by 8, and I get x is equal to 6. So if x is 6, and I sub back into 1 or 2, it's sub into 1. If x is equal to 6, I'm going to get 3 times 6 minus 16 is equal to y. So 18 minus 16 is 2. So y is equal to 2. So you end up with x is equal to 6 and y is equal to 2. I apologize for the numerous mistakes I made this lesson. Okay, end of term. We're all knackered. That was your last one. There are some sums to do. Look on your notes from the textbook, and then you are finished AP for the term. Well done, Upper Fives. You've done a great job. High five yourselves. Okay, and have a terrific half term. Arrivederci.